Okay, super. Hello everyone and good evening. Welcome, and it's really nice to have you back. It's been like some few weeks, and yeah, welcome back. So in the past few lectures, we've discussed a number of things, and most of which centered about how you can use PyTorch for deep learning. And we went through like the fundamentals of PyTorch, how you could manipulate tensors, and later on, for manipulating tensors, you went very deep into how you can like really train some neural networks that could understand images and predict really, really good. So we are going to a bit dive in some different segments, not really training. Here you want to see how you can track your experiments in which you run, and because you'll be running several experiments and how you could really make account of that at the end of the day. And we'll also like touch a bit on your capstone project. So this today's session will be like quite light, and hopefully we'll have time to answer any questions you have regarding like the past lectures, the subsequent sessions we'll have with you, or this particular course, hopefully, or anything. Just feel free to ask any question. So I'll just get started with experiment tracking. It has just very few lines of code, and hopefully you'll be able to gain a lot from this session, inshallah. So yeah. Just this. So this is the so this is the notebook for experiment tracking, but we'll not be majorly using this. So I'll kind of put you into a kind of so this notebook is here, so you can always run it, but I'll just show you something different, something new. Hopefully, it's something that will be beneficial to you if you haven't come across it. So if you've come across it, so it's hopefully something you would learn again from that. So with experiment tracking. So like we said, you'll be running a lot of experiments, you'll be training different kind of models. And if you look at it, there are like different aspects of your experiment because in the life cycle of training a model in which we have seen or in which we've talked about. So first, what you have is this particular box of, and first what you have is here, and let's call this like your data. That's what comes into your model first, and which is very, very critical and very, very important. Then what next do you have is maybe you have something of, then you have like the model itself. Then finally, after the model, you get to make some important or valuable, let's say, predictions. So you have like these three segments entirely. So anything can vary when you are training your model or when you are trying to improve the accuracy of your model. It can be your data, it can be the structure of your model. And because when your data changes, so definitely your predictions or your model performance will change at the end of the day. So there are like number of dynamics, and what you want to do is like to keep track of this because just look at like in a normal lab, maybe someone's a scientist somewhere, so you do like various mixtures together. At the end of the day, you hope to get some results, but you want to keep track of some of the intermediate results you've gotten, good or bad, so that you don't get to repeat them over and over again. So similar way we do experiment tracking in machine learning or deep learning. And in essence, we'll look at, in this particular session, look at how you could do them, why they're important, and how you could do them. There are a number of ways to do them. So just a quick question. So what do you think we should be tracking in when like training our deep learning model? So what are like key components you feel like should be tracked when you want to train your neural networks based on like the past sessions? So what do you feel like changes when you are training your neural network, and what do you think would be good so that we can track them? So you can just kindly comment on the chat, or you can feel free to unmute and just speak. Yes. Okay. Hello, can you hear me now? I think there's come. Okay. Okay, okay, super. Yeah, so kindly comment. Let me just hear from you. So based on my question, and what do you feel you can track in your machine learning model when you get to train like this particular model? Yes, so there is a comment from Abdulkader. He said input data, which is good. And there's some comments from yes, there's training weights. Abdulwasiu said it's prediction. Good, thank you. And there's a comment from Abdurrahman said we should track the model parameters, which is good. And there's comment, okay, loss, training loss, nice. So thank you so much for your input. So you're all like very correct. So for my own, like as far as I'm concerned, you should track everything. So particularly like things that are important to you, because sometimes things that are important to me might not be things that are important. So you need to what do you prioritize? So if the training loss is very important to you to help you like gauge the performance of some particular metrics, 100% track them. So in essence, anything that's important to you, just track them. So for me, let's say I do some maybe low-level machine learning systems. So I might be interested to see how the GPU performance works. Maybe when I'm training some particular model compared to when I'm training another model. So I track the GPU performance and might not really bother about the model performance itself, then I track that. So as much as possible, track what matters to you, but almost everything is trackable. So based on like what we have explained. So let me just go a bit. Yeah, so thanks so much. So your comments have really like answered some of the key questions, but just to highlight some other important examples in which you talked about. So let's say you have, let's say your data, and this is, then you have your model, then you have some kind of prediction. Don't mind this. Prediction that your model does. So at the end of the day, so you can like kind of measure everything like end to end. So your data set can be varying versions of your data, or even data set of the same type. You might train them on some particular subset of the data. Maybe you can maybe call it the range of the data itself. Then for the model, so you can also monitor your weights, but in monitoring the weights, I would say there are different ways to do that. So you can either checkpoint your weight. So what it means, you save like the values or the numbers that your weights have as a form of file in which you could reuse at some particular point in time. But easily you can easily just track these numbers. You can track the model weights as someone had said before. Then you can also track the gradients and you can track hyperparameters. So this is like one of the very key thing that you should remember when in your all your experiments. So always track the hyperparameters because which will come to why you do the experiment tracking is for reproducibility. Because if you don't track the hyperparameters, assuming you train your model on maybe 10 epochs on the learning rate of maybe zero point 0.5, and it gives you like a really good result, and you want to try something else because you don't know what you will find, and you try maybe zero point 0.1, at the end of the day, it doesn't give you good results. And let's say you've done a lot of number of experiments and you've forgotten the actual one that gave you really good result. So it's quite difficult to like backtrack and get that. So you have to do like several other experiments. But if you have this experiment track, it's easy to see and visualize what's happening at the background. And in the same way, you can also track the predictions, that's the performance of your model, and also probably the output of the model. So sometimes it's easy to just look at the performance. Your model is performing in classifying between cat and dog is performing about 90%, but you don't know actually what the model is predicting. So in that particular case, it's also good to kind of track the output or store the output so that you yourself as the machine learning engineer or deep learning engineer can easily see it and see what actually is happening at the end of the day. So it's not, it can go also beyond images. It can be audio or voice or anything. So you can track almost everything. So anything that matters to you at the end of the day. And when you come to present your result, you can see my model performs 90% accurate on this particular task of classifying cat and dog, even for really complex tasks. But I think it's unimaginable to see like this particular image, a simple image of a cat, it can't really classify it well. Then to make you or help you go deeper into to see how your model works and see what you can improve at the end of the day. So this is like the major things of why or what is experiment tracking and what are the things you need to track in your experiments at the end of the day. So I'll just pause a bit, just if anyone has question, then I will answer it. Mm. So feel free to drop your questions at any point in time and happy to talk about it. So, yeah. Yes. So I think I'll just go on in the meantime. So I think one important thing is why should you track your experiments? And I believe like we've talked a bit about it within the sessions, just like a bit. So one important thing is reproducibility. So you want to reproduce your results you have, because imagine you run your experiment of training a really good model of classifying cat and dog and you tell me it's 90%. And when you send me your code or some kind of aspect of your code, I can't really reproduce that. So it becomes like a problem. So you want to like keep these values in store so that you can get to use them for yourself or for anyone else or someone within your team of deep learning engineers so that you can easily use them at the end of the day. So one other thing, it helps you to compare results. So let's say you have one model that performs really, really well, and you have another model that performs maybe similarly. So having tracking like your health parameters or the training performance, as someone mentioned, like training loss, so it helps you to see or compare effectively as we've done before. But in the sense in which you don't track the experiment, it's likely you run your code over and over again. So you don't know what was the initial percentage, or likely you might probably write it down or note it somewhere, but it's a bit difficult for you to manage. So by having them in store, you can see like you can have like really nice visualizations at the end of the day, which you will see. And I will show you how to do that with this particular neat tool called 1DB. So hopefully it's something you will learn at the end of the day, and it helps to like debug again and finally to collaborate with people, because at the end of the day or in the near future, our hope or aspiration is you work with a team of deep learning engineers. So when you work with such people, you want to be able to share your results, people to see your results and easily comment on it. So with this particular tracking tools, it helps you to keep track of your experiment, which is most important. But another key thing is help you to kind of share results with other people so that they see and get to help you or help essentially to collaborate with other people. So you can see this kind of image, which typically happens in even our daily lives when you try to prepare documents. So you can see like model results one, like lots of different variations of names. But if you don't track those results, like as this, it's like a mess already. Then when you come to really large scale experiments, you can be running up to 100 or 200 experiments or ablations. So if you don't track your experiment really well, so it becomes like a a micro hell for you to deal with. And you have to be going through every result and it's like difficult. So there are a number of ways to track your experiment. One is a more popular one is the TensorBoard. So this was actually originally from TensorFlow. So, and you can also integrate it into PyTorch. So we can definitely integrate it. So this tutorial, particularly in this notebook, is about how you can integrate TensorBoard or use TensorBoard with PyTorch. Then you have this width and bias. So easily, it's like commonly referenced as 1DB, which personally I love and enjoy. And hopefully I would like show you a bit of it. Hopefully you get to like it too. But feel free to run this notebook on your own that uses TensorBoard and see for yourself how it is. And you can compare with the 1DB, which I will be showing you in this tutorial, and see how it's going to be. So they have like some kind of key or subtle differences between them. So personally, I enjoy using 1DB because it's more, how would I put it? So it stores your results for you both locally and on the cloud. So you can see it online or on the web interface. So it's easy. So your computer can crash, but your results are still on the web. Then you can easily use it at almost any point in time. Then it facilitates for really real-time collaboration with people and you get to use it. But you will get to see for yourself. Then hopefully when you perform the experiment, you will get to see which you would prefer at the end of the day. So yeah. So like I said, like this notebook is here. So feel free to run the notebook as you want. So this uses TensorBoard. And but for this tutorial, I'll be using this. Just give me 1 minute. So this is just a very small tutorial of 1 dB. So, so let me just show you. So first, like for 1 dB, before we start, I'll just show you the interface for it. So this is like their main website and they have like really cool marketing stuff. So, but when you log in, essentially what you would see is this, but don't worry, I will take you into it. So first you have what you call projects. So these projects can be anything. So, you can have a number of things. So your projects can have runs. And yeah, so this is the interface, but don't worry, I will get you into it. So for the coding part, first you need to install, okay, one minute, let me see. Start session. So first you need to install like the 1 dB here. So with your normal like pip install, if you don't have it already, so just a minute, so it's installing, yes. So after you've installed, so first to use it, since it's a Python package, first you need to import it here using the import 1 dB. So this is the name of the package in which you use. So this is a library that helps us to manage or track our experiments. So once you import it, so if you are going to use 1 dB, you want it to send your results for you to the cloud. So how it works is with 1 dB, let's say you have some results here. So these are like results from anything. It can be from your hyperparameters or maybe your model performance or anything. So what 1 dB does for you is, let's say you have this 1 dB. So first, what it does, it stores anything you want or any metrics you want on your local machine. So your local machine simply means your computer in this case. So it stores it like a file for you on your computer, and you can easily use it on your computer at any point in time. So at the same time, if you wanted to, it can like send these results for you to the cloud. So if it's in the cloud, it means it's no longer on your machine. So you can, but you can use it at any point in time. So that's what it does. So here, when we try to log in here, we're just telling it like, you just want to log it to the 1 dB server on the cloud so that it can send your results. But if you want your results to stay on your local machine, so no need to log in. But here we are going to log in just so that you can see how it works itself. So yeah. So here I'm logged in. So for here, if you were not logged in before, it will ask you for some key. So this key, you can get it from the website after you've logged in. So I will quickly just show you how, but you can do that on your own. So typically what you have is you have this website, and by the top right here, you can get some additional options. And when you go to user settings, then the key is just for majorly for authentication to know who you are and where they will log the result or where they will send the results to. Then immediately you could copy this, and it usually asks for the key just beneath here, and you can just paste the key there. So, and you are logged in. So far here, what it's telling me, I'm currently logged in as this particular person. So any results that is generated from my experiments will be sent to this account here that you see here. So that's majorly it. So here we are logged in. So if you have any questions, just feel free, or any point is confusing, happy to answer any questions at the end of the day. So after you are logged in, so you need to initialize what you want to see your project. So essentially, like what the project means is, yeah, it's just like any normal project you have. So when you initialize a project, it tells it like any experiment you run, it should be saved within that project. So you can have like several different projects. You can have probably a project for maybe deep learning for protein prediction. You can have another project for maybe deep learning for Arewa data science. So just like a project, just like some kind of your own personal categorization of the experiments you run. So in this particular initialization I want to make is I want to create a project that is named like this, Arewa data science. So I don't need to have created the projects on the cloud. So it automatically creates it for me. And I tell it for this particular run that I want to make, So you can just say this in name. So let's say in the project, you can have several experiments. So one of the very first experiments I want to run is a 5-layer neural network, and it uses Adam Optimizer. So that's the name of the project. So you can have different name, but if you don't select this name here, it gives it some kind of random, really nice names. So maybe you can try it and you can see it yourself. So essentially what this block does, it initializes a 1 DB project for me with this particular name called Arewa Data Science DL project. And for the run, so that's like the particular experiment I'll be trying out now. So it's like a 5-layer neural network with Adam. So, but just like some naming. So just feel free to use any naming convention you feel like. Then I will run this. So as you can see, it's telling me you have this, it's locally stored here, and it's also there on the cloud on this particular place. So if you want, you can either click this to see where it is on the cloud. And besides, this is like entirely free. So you don't need to like pay any amount of money. So it's totally free. Then you can see I have a run here called 5-layer CNN. So here it's empty because I haven't run anything. I haven't run any experiment. So it's like totally empty here. So let's see, we've initialized a project and we have a run name. So you can set some configurations. So one of the configurations I want to set that will be stored for me in my 1DB is I can set like the learning rate. This is the learning rate I'll use. This is the number of efforts. This is the number of batch size, just so that to track my experiments. So these are like the hyperparameters we talked about in your project. So it can be anything. You can store the configuration anything. So you can put maybe configuration dot maybe auto. I can put maybe my name here, Mustapha. Now I run this. So essentially it saved this as the configuration for me. So, and yeah, so it's just like a normal dictionary that you know, or a Python dictionary. So this helps a lot because when you send your experiment, so you have this at the end, because this is like tracking we are talking about. You are tracking the learning rate, the effort, and the batch size that you have. So at the end of the day, so this is just a microcode to generate some numbers. So these numbers can be anything as we said. So just to go over this quickly. So assuming this is like a machine learning model that's generating some values. So we go over this for a particular number of epochs. So it can be based on our configuration. And let's assume this is some like pseudo or fake loss, like similar to our model. And this is also some like some accuracy, assuming our model generates this. So one important thing to know is we want to log this, that's the loss and the accuracy. So what we can do is we call 1DB and simply call .log and pass it what we want it to track for us, which is our epoch and loss and also like the accuracy. And simply we can run this. So when you run this, so it runs for 10 times based on like the epoch we set. But this is the most important thing you should learn. And it's like really simple and it helps like a lot, really a lot, trust me. So you track your epoch, you track your loss, and so easily you can see it's run already. And let me just clear this. So after running this, so once you've logged this, so you can either, if you want, you can continue, you can either check your dashboard online, and maybe let me just refresh this. So automatically you can see it generates the plots for you. So even without you using the 1DB tools, the matplotlib tools, so you can see easily it generates the plots for you and you can easily visualize. So this is just some like fake numbers. So, and yeah, then, so this is for logging what we call like scalars. So these are like just pure numbers or some pure like values. So you can log almost everything like we said. So one other thing you can log is images. So here, this is a simple code to show you how to log images. So here simply, you generate some linear numbers from 0 to 10. Then this generates like some sign of those numbers. Then this is like a plot. a matplotlib plot. So this is just a matplotlib object. Then what you have from that object, you can log it. That's the output of what you have. So this essentially still calls the 1DB library we have, then you call log, then perhaps the name of the item you want to log. Then you can call this really neat method, 1db.image, telling it what you want to log is not actually a scalar value, but it's something of the object image, and you pass it an image. So this image can be anything. It can be any image you load with matplotlib or some other any image library. Then you send this and you log this. Then let's try to run this and see if it will appear on our 1DB. So this has been generated. Then let's see. Let me just do this. So when you look into this, so maybe most times you don't need to refresh. So you can see under media. So media holds everything else that is not a number. So this is one of which is an image. So you can see we have our image logged in for us. And as you can see, this is not on the local, this is on the cloud. So even if I cancel everything and I delete this cluster or my data gets erased here, so you still have your results on the cloud. So that's the like really nice thing about 1DB. And so apart from this, you can save almost anything else. So essentially, if you want to save anything else, they call it artifact. So it can be audio, it can be anything. So you call it artifact, then you send the artifact to 1DB, then you just log artifact. So simply what you call is like the artifact class here, then you pass in the name and just the name, then like the type. Then essentially you add the file here, then finally you log the artifact. Just in like some really simple key steps. By the end of the day, what I would love you to remember is this 1db.log. So this is like the most important thing at the end of the day. So to remember 1db.log, then you can almost log almost like anything else. So you can go really, really advanced with logging your gradients, your model weight, and a lot of number of things. Just to quickly, yes, just quickly, don't worry, we'll show some visualization. I'll show you some other experiments I've run. Then after you're done with logging, so at the very tail end, so what you do is run.finish, just to tell it like you finish your particular run, then it kind of terminates at the end of the day. So you can see this really neat history, but I think our most important is like what you have on the web here. So yeah. So and on the line, what it does is just give me one minute. Let me see. Yeah, so it also like tracks other things for you, but these are mostly not important. It tracks like your network traffic, it tracks your disk utilization, and it depends on your, like I said in the very beginning, so it depends on what you want to measure, but it's super cool when you get to use 1DB at the end of the day. So that is mostly essentially it, but let me just show you one more thing based on so if you have, you can have like a number of projects as you want, and you can get to use them. So once you have that, you could also like create some really interesting reports. So these reports can help you at the end of the day. So you don't need to really go between documents or creating files. So based on the results that you have generated, then you can. So here I'll just show you some quick example about some. Okay, let me do this. Okay, let me just show you. This is like some old experiments that I've run. So here you can see from this, like from the results I've generated, so I can easily create and edit this document. So it's more of like a mini document, and you can easily like add your results and see it, visualize it, and see it with everything. So as we said, like if you can track your results, help you with collaboration. So I can easily send to anyone. So anyone I want to, I can share with you or your colleagues, especially let's see when you get to do your capstone project. So you can almost share with everyone and they can easily use it at the end of the day. So so I would say that's majorly about the experiment tracking. So as you can see, it's kind of quite easy. It's just some simple overlay of what you've learned so far and with some maybe less than 10 lines of code, you could track your experiment in a really nice way and you can share and visualize with almost, you can visualize it for yourself and share with almost everyone else. So, but let me just see if there are any questions on the visualization or on the experiment tracking. So it can be anything. So I'll just see. So yeah, just feel free to ask if there are any questions you have. So, like I said, with the original notebook, what you have is based on TensorBoard, and you can use that. So, feel free to use that. So, and if you want, you can also use 1DB. So, for me personally, I mostly use 1DB, and even though a bit of using TensorBoard also. So, yes. So that's majorly it for visualization. So hopefully it's nothing complex, but if you have any questions, feel free to ask now or probably later on. Then we would switch gears a bit. So now I will quickly like discuss about.
Hello, sir. I have a question.
Yes. Yes, please.
So, for example, you made mention that we can run an experiment and then change the parameters, maybe the learning rate or something like that,
Yes.
then rerun it again. So,
Yeah.
I'm just curious to know if, like, we have to end the first run before changing, for example, the hyperparameters and then rerunning
Mm.
for it to be separate, you know? You get my point? Or it will be automatically different.
Ah,
You get that?
okay. Okay, okay. If I get your question correctly, is more of like if you are running your experiment, should you do this finish, like this run dot finish, right?
Yes, like after I set some hyperparameters, then
Yes.
do I need to like run it, finish the run first before changing the hyperparameters and testing the model again, or?
No. Yes, thanks so much for the question. You don't need to finish the run. That's the very simple answer. So even let's say I omit this at the end of the day. So at the end of the day, I think this is just a flag to tell 1DB on the cloud it is done. But even if you don't do this, if it terminates in any manner, so it's still like counted as finished. So one thing, like you said, if you run this, so you don't need to terminate, or you can terminate at every point in time. You don't need to call this run.finish. So then what again? Then when you run it, if you change your hyperparameters, so let's assume, so we can do a simple scenario here. So I can restart this runtime, then quickly restart this runtime and maybe quickly run this again. Hopefully, no need to install. Then, yes, no need to install. Then let's see, you have 10 epochs. Then this runs, yes. Then you can see right now I didn't call or I didn't run this cell for run.finish. So I can also go back and change these hyperparameters to probably 5 or change this to anything else, maybe 3. Then I can set perhaps a new experiment. But if you want, you can rerun several experiments again. Maybe you didn't change Adam or it can still have like the same name. So you can still see it like counted at the same, which you will see subsequently. Then just to get some varying results, I can change this to probably 5. To maybe just to maybe 9. So I'll just run this. So you remember like I didn't call run.finish. So and I'm
Yeah.
running again with another set of experiments. So easily you can see it. So we can go to our projects. Then we have this Arewa data science project. And you can see it has created
Okay.
a run for us. So you
Yeah.
don't need to like do okay, I think let me just run this. Can you just give me 1 minute? Yeah. So you don't need to like entirely like terminate the previous one. So it kind of gets to create it over and over again. Then you can see like the what I'd like to configurations used before. So if you open this file, no, not this file. mm, Give me a minute. Mm, okay, I'm going to just give me 1 minute. Yeah, you. Yes. So if you open this file, then you can see like the set of hyperparameters you've chosen before. So, and you can see like some kind of metrics. So this, if you remember, these are like the configurations we've stored. But okay, I think nothing changed. Just give me a minute. Hmm. So just 1 minute. Let's retry this again. But I think you might need to like run, okay, I think what you might need to do is like run the initialization over again. So first you need to like run the initialization over again, but you can stop at any point in time. So you don't need to, I think most importantly, you don't need to call this run.finish. Even if it's at like 10 epochs and it's, let's say out of, you're running, let's say 100 epochs and it's like 10 or 50, then you can stop it at any point in time if you're not convinced of the results and it will like terminate for you. Just so that to prove the point here, I can show you a bit of some few experiments. Let me see. Okay, let me just quickly show you this. No, okay, let me show you this. So you can see like for this experiment, I have one at 1K step and I have one at 600 steps or 500 steps. So I've like kind of mostly like terminated this or several, let me just undo this. Yeah, or this or at 450. So you can terminate at any point and when you rerun again, so automatically starts a new run for you. So as far as, even if you don't change any of the like hyperparameters or configurations, so it kind of creates a new run for you and you can always see that. You can see like what time it's being created and what time and other anything that's essential for you. It kind of locks everything for you automatically. So here you can see when you run the notebook, you can see like other key things with your that's related to like the experiment tracking that you've provided to your model at the end of the day. Mm.
Yeah. Thank you.
Yeah, no, yeah, thanks for the question also. Yeah. So yes. Yeah, so that's majorly it for model tracking, but still, so quickly I'll just switch gears a bit to like the very, so far after this session, you have like one, hopefully like one lecture session, which is based on experiment replication or replicating papers. So hopefully we'll have that next week. Then in the subsequent session is mostly like a kind of discussion between like the groups we'll be having. So which is majorly centered about this capstone project. So like we said, you have some weeks of like lectures and exercises. Then finally you have this capstone project. So the idea of the capstone project is to help you solidify what you've learned, apply what you've learned to solve some kind of real world problem at the end of the day. So our aim is to group you into like groups of 4 or 5 people and you work together and you work on almost anything you want. So, but you apply like concepts in which we've talked about, like the CNNs and the convolutions or using transfer learning. So just feel free to choose any problem and based on like your group or anything that you would be comfortable with at the end of the day. So difficulty doesn't really matter for us. So it can be something super complex as far as you can handle it within the time frame and it will be good. So our aim is for you to try to finish between 4 to 5 weeks. So the final deadline for the submission will be May 25th. So don't worry, we'll give you much more concrete details about this, but just to give you some maybe little information so that you can get ready at the end of the day. So we will have like a final project feedback. So based on the project you have worked on or have selected to work on, you and your team members, we'll give you like some concrete feedback on it and some really key suggestions, which will be hopefully be valuable for you in your career or what you get to do next. Then that will be like almost all for the fellowship, and tentatively by June 14th. So yeah. So, but the requirements for you to, so we want to make it so that it will be as active and engaging as possible. So, what we want, like doing like some teamwork, it takes like a lot. So, it can be kind of difficult. Maybe one person is doing more work than the other. So, just so to hope to balance things. So, we want you to, hopefully, you must have completed all the previous exercises. So, if you don't have or have not completed any of the exercises, please do. You have this week and hopefully the next. So try to please submit your exercises so that we can grade them, so that before we do the group allocation, which would be out by next week. So if you try to complete up from week 1 to week 6 of the exercises, if you have any challenges, always reach out to us either on Discord or email. We'll be hopefully be there to help at the end of the day. so that if you have done the exercises, at least you have some idea. And when you do your group discussion, you'll be able to kind of contribute to the group, no matter what you are doing, either writing or doing the experiments or data manipulation or anything. So, and at the end of the day, we hope to have like two deliverables from each of the group. So one is your code. So your code can be on GitHub or anywhere. It can be just Python code or some Google Colab notebook. So we are fine with that. Then at the end of the day, also we want like some 2 to 3 page mini paper research paper. So don't too bother about the complexity of this, just to get you into like research. Hey, I build this model for classifying some really niche disease between yeah, some classes of disease, and this is what we found. This is where the scenario where the model works, and this the other scenario where the model doesn't really perform well. So just more of like to kind of interpret the results you have to anyone reading and understanding it. And one key thing about the code base, we would love it for you to deploy it on the cloud or anywhere, just so that anyone can use it. You can share it with your friends or colleagues, and they don't really need to know the key details of the models you built, but at least they can use it. So it can be some crop disease detection model. They can just plug in an image and use it easily. So don't worry, we'll be there to support you at any point in time. So the kind of support you will have from us is one, you have weekly support. So you have like weekly catch-up sessions with each of the groups. So we kind of discuss with you, you tell us your challenges, and hopefully we get to support you. And you have like mentors for each group. So the mentors are here and they've been doing a good work. And most of the mentors have like done the project before. Hopefully they'll be able to give you their experiences and help you do like much more better than what they did, or their most of their learning points. So they did really good projects. So don't be worried about it. That so they'll be there to support at any point in time. Then feel free to catch up with us by email or Discord at any time, apart from the weekly catch-up sessions. So hopefully we're able to answer your questions. So the questions that I'm saying, it can be anything. Just feel free. It can be technical, non-technical. It can be any question at the end of the day. Just feel free, please. So that's the support we hopefully to help you facilitate you finishing the fellowship and most importantly, learn more from this. And yeah, so just to recap, I know we've mentioned this. So these are like a few of the projects some of the students did, and some of them are here on the call. Then you can, if you want, you can peep out their names and see. So one of which is like wildlife conservation classification, which is like a really cool project with the general challenges in wildlife. So another is food detection. If you like food, then you can easily use AI or machine learning to classify food. So they did some really good work also here. Then this is for disease classification. We know how rice is important to the country. Then they build a really nice model. So this, don't feel this is nothing, don't feel overwhelmed by this. So it's something you can equally do. So hopefully we are looking forward to see some of the projects you will build at the end of the day, and also give you like some key information about this. So this was for the last one, so a bit of information for them. So we'll update this and send to you before by next week, hopefully, by next week. So I would say majorly, that's majorly it. So I think there's a question from the chat, but also feel free to ask your questions if you have. So there's a question from the chat. When tracking the performance of the model, are we setting the config in the training loop? So not really. So the config is outside the training loop. So in your training loop, what you majorly track is the model performance, which is like the loss values or the accuracy, and it can be the model gradients or weights. So that's what you track within the training loop because that's what changes. Then outside the training loop, the config are majorly stationary. So those are like some hyperparameters you set within your model. So most stationary things, you just store them as config because you know they don't change in training. So one of which is the like batch size and perhaps the optimizer. But anything that you feel might change, then you can put it within, you can log it within your training loop. Yes. So someone is asking about the link to the Discord. Please, Bala, can you kindly share the link to this Discord here to the chat, please? Thank you. And yeah, so that's majorly it from today, but I'll just hang on a bit for a few minutes if you have any questions. So happy to answer if there are any additional questions. So there's someone I cannot find the exercise from 3 to 6 on GitHub Arewa. So 1 minute, let's see. So by the way, we've started like reviewing some questions from or some of your submissions, and hopefully you've been receiving feedback. So we've had like a number of submissions, so it's like taking a while, but the mentors are doing like a really good job. Hopefully the feedback have been quite helpful. So so this is, if you look at this, so this is like our page for the Arewa Deep Learning Fellowship. So this column here has the exercises. Then each of this has like a link. So the question was not having, we can see here there is, okay, for week 3, okay, okay, thanks so much for that. So there is the one for week 1, and week 2 also has like exercises, but there's none for week 3. We'll update that in a bit. Then week 5 also has, and yes, let me see. Just 1 minute, let me just check the question again. Yeah. Okay, week 3 to week 6. So I feel like there's none for week yeah, so for week 3 we'll update it, but actually I think you can find it from the original repository, but we'll update this so that you can find it. Then for week 6, which is the transfer learning, we'll also like update that for you. Yes, thank you so much for pointing this out. So for week 5, it's available. So for week 5 is custom data sets. So this is like the exercise for week 5. So I believe for week 3 and 6, that's the one we'll be updating. So thanks so much for pointing it. Then we will update it as soon as possible. Then let me see. And yes, please, there is a question from Utebi Abasi. Mm.
Okay, okay. So thank you, sir.
Yeah.
I wanted to know the deadline for completion of all the exercises so that we can be
Yes.
grouped.
Okay, okay. So deadline for completion of all
Can
the
you hear me?
yes, I can hear you. So if I get correctly, you are asking for deadline of completion of all the exercises, right?
Yes, if you say for the capstone project, the
Yes.
prerequisite is you must complete all the exercises from 1 to
Yes.
6.
Yes.
So before you are grouped or something. So when is
Okay.
the
Okay.
deadline?
Yes. So the deadline would be exactly let's say Saturday. Let me see. Let me just confirm the date. Just 1 minute. Mhm. So the deadline will be like exactly next week. So or next week Sunday rather. So but we'll send an email on that just as a reminder for everyone. And feel free to email us if there's anything else, but we're exactly on the 27th. So that hopefully you get to finish that on time and also hopefully get to start on the project with your team members because we will release it subsequently like by the Monday or Tuesday on the 28th or 9th. But we'll send you an email about like details of this. But I would say on a personal level, try as much as possible to finish as much as possible. So perhaps maybe 4 to 5 out of 6 of the assignment. So that's on a personal level, but as much as possible, try to do all. But deadline is 27th of April. So you need to hopefully submit everything. Yes, all the exercises.
Okay, sir. I have one question also.
Yes, please.
Is it only from week 1 to week 6? What about the rest? Or we should just let them be? And
Yes, for the other weeks,
can
don't
we get,
worry. Yes, go on, please.
can we get the link for the 1 DB that you have just do the
Ah,
tutorial on?
okay, yes, I will send the link. Yes, please. For the exercises, just focus on week 1 to week 6 because those are like the essential thing. So any other thing after that, because right now we are week 7, so you would learn it while doing the course project. So the most important learning point for you is from week 1 to week 6. So those are like key and fundamental things that you will get to be using in maybe as you go on in your career in let's say deep learning. So don't worry about like the rest of the exercises. So everything would be that are compressed within the course project. I'll give you like details about this. Don't worry about that. Yes. So I will send the link to the 1DB now. Yes. Mm. So someone mentioned is having like difficulty in submitting the exercises. So please, you can tell me if you want. You can tell me what the difficulty is now. Then hopefully maybe we can advise it now. But feel free to also send an email or to our email or to the Discord. So we're very happy to. If you want to ask the question now, you can talk about the difficulty you have submitting. So, but if there's anything else, just let me know. So I think that's majorly it. Thanks so much, Bala, for sending the link. Yeah, so that's majorly it today. I hope you did enjoy the session, but feel free to reach out any point in time, either on Discord or anywhere or email. So we are happy to help at any point in time. And yeah, thanks so much. I hope you enjoy the rest of the week or weekend. Yes.
Thank you. Bye.
It was a pleasure. Mm.
Ah.
Yeah, thank you.